So for example 2, it tells us a person invests $1,000 in an account that earns 5.5% annual interest. Find when the value of the investment has doubled. So it tells me that my principal, right, my initial investment was $1,000. Our R is 5.5%, which is 0.055 as a decimal. So our V of t is going to be 1,000 times 1.055 to the power of t, because we're going to add those two together, 1 plus 0.55. I'm just going to kind of skip that step a little bit. And we're going to take that, and we need to know when, what t. Right, so I need to find t when v of t has doubled. And so if it starts at 1,000 and I want to know when it's doubled, that means I want to find when it's 2,000. So where did the 2,000 come from? Again, it's that statement where it says doubled. So again, we're going to go back to Desmos. We're going to use that as our equation, then use the 2,000 line to figure out where those intersect. So we're going to jump to Desmos here. We'll do 1,000 times 1.055, and we want to know when it's doubled, so 2,000. So we're going to zoom back out again, scroll down. So there's my 2,000 line. Zoom in and tap, and we see that's at 12.946. So t equals 12.946. So we can say it will take approximately 12.9 years. For that value to get doubled. So those are examples 1 and 2. Okay, when we are compounding the interest annually, meaning just once a year, every year. Now, if we want to compound it more than once a year, because this is also a pretty common thing to do, when we compound it more than once a year, I actually have to use a slightly different equation, and so that's going to be this one here. V of t equals p times 1 plus r over n to the power of n times t. So this new little variable here, n, is just the number of times we're going to compound the interest. Okay, so we have to be careful with a couple of different types of words here, because those words are going to tell us how often the interest is being compounded. So if it says annually, well, annually is, again, every 12 months, right? Every year, so it's only one time per year. Semi-annually would be every 6 months, which would be 2 times per year. Quarterly is every 3 months, also known as 4 times per year, right? A quarter of the year, so 4 times per year. Monthly would be every single month, which means we would do it 12 times per year. I'm going to rewrite that one. 12 times per year. And daily, pretty obvious, meaning every day. And so that one would be a whopping 365 times per year. And yes, there are leap years that have 366 days. We just assume it's 365. Okay, that's just what they go off of. They don't worry about leap years. They just do it at a 365 rate. So again, very similar. The only difference now is we just have to worry about these numbers right here. How many times is it being compounded? Okay, all of those are the n. Okay, how many times it is being compounded, how many different interest payments are getting made throughout the year. Okay, so example 3, a person invests $1,200 in an account that earns 2% annual interest compounded quarterly. So it tells me quarterly. That's kind of my key here. That means it's 4 times because my year is split into quarters. Find when the value of the investment reaches 1,500. So from my information, my problem, it's telling me my principal amount, my initial amount, is 1,200. It tells me that my rate was 2%, which is 0.02. And my n, right, the number of times it's compounding yearly, is 4, because it's compounding 4 times a year because it tells me quarterly. So as we put this into our equation from up above here, v of t equals p times 1 plus r over n to the power of n times t. We get v of t equals our principal, 1,200, times 1 plus my r, which was 0.02, over my n, which was 4, to the power of 4 times t. And again, I wouldn't even worry so much about necessarily solving this. To be honest, I'd probably just put that as is into a calculator. If you want to, we can, right? We can go to Desmos really quick and figure out what that is. 0.02, oops, 0.0202, thank you, divided by 4, 0.005. So if we add 1 to that, we get 1.005. So if you want to write it in that way, you can, and just know that that's 1.005. I'm not going to be super picky either way, because again, this is just a matter of using Desmos to figure out where it crosses anyway. So in this case, we can see that we have 1,200 as our principal. So I'm going to go again and use that equation up at the top. So 1,200 times 1.005 to the power of 40, because remember there was an n up there. So I'm going to go back down to home, and there's my graph. I wanted to know when this value becomes 1,500. So we're going to zoom out, find that 1,500 line, see where they intersect, and it's at 11.185. T equals 11.185. So we can say it will take approximately 11.2 I'm just going to shorthand that, approximately 11.2 years for the value to reach 1,500. So again, a lot of it's kind of the same idea. It's, can we create an equation and then just know what line we have to have it intersect, and then just figure out what the x value is. And if we can do that, we can gather that information. Now it's just a matter of, can we set up our equation with the right variables using the information in our problem to know that we have it set up correctly based off of how our interest is compounding every year. So that was example 3. Again, I would challenge you to try example 4 here down below on your own. So now would be a good time to pause the video and try it, and then come back, let it play, and see how you guys did. So for example 4, a person invests $8,000. So my principal is going to be 8,000. My rate, it says, is 6.5% annual annual interest. And so that's going to be 0.065. It also tells me it's compounded daily. So that's kind of my keyword there, daily. And so that tells me my N, how many days are there in a year? 365. So as we write our value formula here, we have V of t equals our principal, 8,000, times 1 plus 0.065 divided by 365 to the power of 365t. And again, if you want to figure out what that is, because you don't like seeing the 1 plus some ugly gross fraction, and you want to just combine that into a single number, you absolutely can. You can just go back to Desmos, can use our calculator to help us out there. 0.065 divided by 365 plus 1 gives us a really big decimal there. So again, that may not be worth it to try to write that down, because you really don't want to round until the very end. So I wouldn't if I were you. So in this particular case, seeing that crazy decimal, I would just type in that entire equation. So I'd go our 8,000 principal. We have times, I'm going to use our actual whole equation. So 1 plus 0.065 divided by 365 to the power of 365t, which gives us this exponential graph here. Our V of t in this case, we want to know when does it reach 20,000. Right, find t when V of t equals 20,000. So again, use Desmos, type in that V of t equals 20,000. Got to go find our line. Zoom out, zoom out, zoom out. There's our line. Zoom in, zoom in, zoom in. Find where those two intersect, and we get 14.098 is our answer there. So t equals 14.098. So when will that investment reach $20,000? It will take approximately 14.1 years to reach $20,000. So there we go. That is, again, just some examples of compounding interest more than once per year. Again, using that equation 1 plus r over n to the nt power. Again, just trying to figure out how many times is it being compounded per year. Okay, and it'll have to give us either annual, monthly, daily, quarterly, something. It'll have to give you some descriptor there for us to be able to use that. Okay.